In this video, we're looking at 2021 paper 2 question 9, and it's all about trigonometry. We're given a triangle that represents the flight path of a plane, and we know that the distance from C to A is 1,450 kilometers, and that the angle here, the angle CAB, is 8.57 degrees. Now ultimately, in the first part of this question, we're concerned with the flight from B to C. But I want to point out to you that we've been given all the information we need about going from A to B. We're told that it takes the plane 2 hours to travel from A to B, and that the speed of the plane is 420 kilometers per hour. So obviously then we can just work out the distance. It's just time multiplied by speed. So the distance from A to B is 840 kilometers. Now, we know the speed at which the plane is traveling, and we've been asked to work out how long it takes for the plane to travel from B to C. If we know the speed and we're looking for the time, then we also need to be able to work out the distance. So what we're going to do next is we're going to concern ourselves with the distance from B to C. We know the speed is 420 kilometers per hour, and we have enough information in this diagram to work out what the distance is. So that's what we're going to do next. Once we have the distance, we'll then be able to get the time. In order to work out the distance from B to C here, we're going to use the cosine rule. We know two sides and the angle in between it. It's a non-right angle triangle, so when you have two sides and the angle in between it, you use the cosine rule to work out the other side. So let's do that now. So we know the distance traveled from B to C and the speed, and to work out time, it's distance divided by speed. In this case, that works out as 1.5. And it asks to leave my answer to the nearest minute. 1.5 hours is obviously 1.5 hours, which is 90 minutes. In part 2, we're told that the plane uses 3.8 litres of fuel per second, and the capacity of the plane is 100,000 litres. And we're asked to work out, is there enough fuel for the plane to travel from A to B to C and back to A at an average speed of 420 kilometers per hour? So what I've done in the first bit here, this bit, I've worked out how long it's going to take the plane to travel from A to B to C and back to A. And then in this bit I worked out how long the fuel will last if the plane travels. And essentially we work out that one of them is longer than the other. So let's just talk about it here. First thing I decided to do was to work out the total distance traveled by the plane. So add up the distance from A to B to C. When you add them up, the total distance traveled by the plane is 2,921.9 kilometers. We know the speed the plane is traveling at is 420 kilometers per hour. So I know my distance, I know my speed. To work out the time, it's simply the distance divided by the speed, and that tells me that this entire journey takes the plane 6.97 hours. So hopefully there's enough fuel to last for 6.97 hours. I know that every second the plane uses 3.8 litres of fuel, and it can hold 100,000 litres of fuel. So 3.8 into 100,000 tells me that the plane can continue flying for 26,315 seconds. Since I had this in hours, I decided to convert this into hours as well. So obviously I divide by 60, that gives it to me in minutes, divide by 60 again, and that gives it to me in hours. So I've worked out the plane can travel for 7.3 hours without stopping. And this journey takes 6.97 hours. So clearly the plane's capacity is sufficient that the plane can travel the whole distance, the whole journey without refueling. In part B of this question, we're given a trig graph. We're given the function that represents an alternating current. And essentially here, the first thing we're asked to do is just get the period and get the range. Remember, to work out the period, there's a formula for it, and our period is simply 2 pi divided by the coefficient of our t. In this case, 2 pi divided by 120 pi. In this case, the pi's will divide into each other, and 2 divided by 120, we can just write that as 1 over 60. And since we're told that t is in seconds, that means obviously the period is in seconds. So the period in this case is just 1 over 60 seconds. And to work out the range is simply the coefficient in this case of our trig function. So the range in this case, obviously this trig function oscillates around 0 because there's no constant, there's only one term, but the maximum is going to be 110 root 2 volts, and the minimum is going to be minus 110 root 2 volts. So that's going to be our range in this case. In part 2, we're asked to sketch this trig graph. Now, nearly all the tutorials we did on this section was all about sketching our trig graphs. So you should try and be relatively detailed here. First of all, I've set myself up to do a nice sketch here. I know the period is 1/60, so I'll be able to do one full oscillation after 1/60 seconds. I know the max is 110 root 2, and the minimum is minus 110 root 2. Remember that a sine graph goes up to the top, down to the bottom, and then reaches back at our 1/60. Our sine graph always starts at 0, and if it's a positive sine graph, it goes up and then down. Now, it did say sketch, but we should try to be as accurate as possible. I know that obviously it's at a maximum after 1/4 of the period. It intersects here at half of the period. It's at its minimum after 3/4 of the period. So I'd work those out. Half of 1/60 is 1/120. Half of 1/120 is 1/240. And once we have 1/4 of the period, we can work out 3/4 of the period. We multiply this by 3, 1/240 multiplied by 3 gives me 1/80. Now, my examiner can clearly see I've labelled where the maximum is, and it corresponds to 110 root 2 and 1/240. I've labelled the first time it intersects the axis, and I've labelled the minimum here it clearly corresponds to these values. So for a sketch, I'm going to get my full marks for that. Okay, part 3 is relatively straightforward. We have a formula for the voltage, and we're simply asked to work out the voltage after 6.67 seconds. So all you do is, instead of a t, you sub in 6.67. Now recognize that your angle is in terms of pi, so obviously you have to have your calculator in radians to get the correct answer here. And when you plug it into your calculator, you end up with 147.95 volts, and that's the full marks for part 3. In part 4, we're asked to find one value of t where the voltage is 110 volts. Now, you should recognize that this is a trig graph that goes on forever. So technically there's an infinite amount of answers, and when we get to the line where we're ignoring that, I'll point it out to you. We're only asked to get one answer here, which makes the question a little bit easier. To work out the voltage, we use this formula. We've been told the voltage is 110, so you just sub it in. Now I've got one equation and one unknown, so I can find a value for t. All I did on the first line was divide both sides by 110. If I divide both sides by 110, I end up with 1 equals root 2 sine of the angle. Then I divided both sides by root 2 and end up with sine of the angle equals 1/root 2. Now, this is where we could go from here and get an infinite number of answers. If we could use our unit circle here. Remember, when we're dealing with unit circle, what we could do is get our reference angle. Sine is positive in the first quadrant and the second quadrant, so you could get two answers in the first time you go around the circle, then two more, then two more, then two more. So there is an infinite amount of answers. However, because it says we only want one answer, don't bother with your unit circle, just get your reference angle and that's the answer you're going to use. So instead of worrying about quadrants and reference angles and all that jazz here, all we have to do is get sine inverse of 1/root 2. And if you plug that into your calculator, it's pi over 4. And then I've 120 pi t equals pi over 4. So what I did on this line was divide both sides by pi, so the pi's simply eliminate. And then on the very last line, what I did here was divide both sides by 120. And I end up with t is equal to 1/480 seconds. And that's one acceptable answer, although there is an infinite amount of acceptable answers. If you went about it getting the unit circle from here, you could get a different answer. And in the final part of this question, we're asked to get the rate of change of the voltage when t is equal to 2. Now, when you see rate of change, you should immediately recognize you need to get the derivative. The rate of change, you get your first derivative, and in this case, we're going to sub in 2, and that'll give us our answer. So let's just discuss how we can get our first derivative here. Really, we're differentiating the sine of an angle essentially, but there's a coefficient in front of the sine, so the coefficient, we just take it down. We don't differentiate it or anything, but it's still going to be there in the answer. Now, according to the maths tables, the derivative of sine of an angle, it simply becomes cos of that angle. So sine 120 pi t becomes cos 120 pi t. But then we have to multiply by the derivative of the angle. And remember, the t it's like our x here, so we're differentiating in respect to t. The derivative of 120 pi t will simply be 120 pi. So in this case, I might just rearrange this. Realistically, we might write it as 110 root 2 by times 120 pi cos 120 pi t. And now all we need to do in order to get the marks here, we just need to sub in t is equal to 2. So all I'm going to do now, sub in a 2 and I'll get my final answer in volts. So all I did here was I subbed in, instead of a t, I subbed in a 2, and my final answer is 58,646 volts.